Welcome to this podcast about sustainable anesthesia in cardiovascular anesthesia and thoracic surgery, where we explore innovations that improve patient care while reducing environmental impact. Today, we will discuss sustainability in cardiovascular and thoracic anesthesia, a field where long case durations, high gas flows, and resource intensive practices make anesthetic choice particularly impactful. Yet, practical solutions exist and it's time to adopt them. I'm Steffen Rex, head of the Department of Anesthesiology at the University Hospitals Leuven in Belgium, specializing in adult and congenital cardiac anesthesia. Joining me today is Dr. Alain Kalmar, staff anesthesiologist at St. Jan Hospital in Bruges, Belgium. Alain is also a civil engineer and a leading expert in environmental anesthesia with numerous publications in the field. Alain, thanks for being with me.
Happy to join. Thank you.
Let's start with why sustainability in anesthesia is urgent. Some argue that volatile anesthetics don't harm the climate because they degrade in the atmosphere, unlike CO2, which persists for centuries. But this, in my opinion, is dangerously misleading.
Yes, exactly. While it's certainly true that volatile anesthetics degrade within 10 to 20 years, that does not mean that they are harmless. During this short time window, they often trap as much heat as thousands times more CO2 would in a whole century. Moreover, the next 2 decades are the most critical window to act. If we fail to act now, we risk triggering irreversible feedback loops in the climate system, such as melting permafrost, loss of polar ice caps, and disruption to ocean currents, which in turn induce additional heating, triggering a runaway greenhouse effect.
So, the claim that volatiles only contribute to warming for 20 years is actually a reason to eliminate them immediately, not an excuse to keep using them. This is the last real opportunity to prevent catastrophic warming.
Yes, indeed. And let's not forget, Desflurane's global warming potential over the next 20 years is 7,020. That means that 1 gram or only 0.6 ml of desflurane traps as much heat as 7 kilograms of CO2. Even sevoflurane, often considered the safer option, still has a global warming potential of over 720. So the cumulative effect of these gases on global warming is undeniable.
Okay, thanks for highlighting this. Let's now turn to total intravenous anesthesia, a clinically proven, safe, and sustainable alternative to volatile anesthetics. However, there's a persistent myth that propofol is ecotoxic, but that is simply not supported by evidence. Am I right?
Yes, right. Propofol is not a persistent environmental pollutant, even though this is very often claimed in literature. Even more, unlike volatile anesthetics, which do persist in the atmosphere and then degrade into per and polyfluoroalkyl substances, the infamous PFAS forever chemicals, propofol has not these properties. It biodegrades efficiently under aerobic conditions in wastewater treatment, and it does not accumulate in the environment the way volatiles do. Even more, propofol has a far lower total emission footprint than inhaled anesthetics. For instance, apart from the fact that volatile anesthetics are very dirty PFAS forever molecules, 1 gram of propofol easily provides 2 hours of anesthesia, while 1 gram of sevoflurane, only 0.6 ml, only provides anesthesia for a few minutes. In addition, it's often assumed that only propofol causes local water pollution, but the renal elimination of sevoflurane metabolites results in hexafluoroisopropanol pollution, which is also a PFAS, and which is of much larger environmental concern than the propofol metabolites.
So, the idea that propofol is just as bad as volatile anesthetic is clearly misinformation. If we care about sustainability, TIVA should be the default choice in most cases. Do you agree?
Absolutely, no doubt about that.
Okay. One of the most indefensible practices in modern anesthesia is using volatile anesthetics during cardiopulmonary bypass, CPB.
Yes, absolutely. It is shocking that some centers still do this, considering that CPB systems operate with, in most cases, high gas flows, often several liters per minute, leading to massive volatile anesthetic consumption. And even with scavengers, only a fraction of the anesthetic is captured, and their real-world efficiency remains unproven. So, no doubt, TIVA is a far better alternative on CPB, providing excellent hemodynamic control and almost zero greenhouse gas emissions or PFAS pollution.
Okay, to summarize, there's no justification for using desflurane or sevoflurane on CPB. It's wasteful, unnecessary, and environmentally irresponsible. Let's move to thoracic anesthesia. Thoracic anesthesia presents additional opportunities for sustainable practices. One key issue is how volatile anesthetics interfere with hypoxic pulmonary vasoconstriction, the body's natural way of optimizing oxygenation during one-lung ventilation.
Yes, that's right. Volatile anesthetics, especially at high dose, may blunt hypoxic pulmonary vasoconstriction, leading to ventilation perfusion mismatching and potential oxygenation issues. TIVA, in contrast, preserves the hypoxic pulmonary vasoconstriction, making it a more physiologic choice for one lung ventilation in thoracic surgery.
Both for cardiac and also for thoracic anesthesia, another crucial consideration is certainly monitoring depth of anesthesia. And this, by the way, holds true for both volatile and intravenous anesthetics.
Yes, absolutely. Real-time depth of anesthesia monitoring prevents many things. Excess volatile anesthetic use, which directly increases greenhouse gas emissions. Also, overuse of propofol, which can lead to unnecessary drug waste and prolonged recovery times. And also ensuring that we give exactly what the patient needs, nothing more, nothing less. In addition, since TIVA lacks the equivalent of end-tidal anesthetic gas monitoring, depth of anesthesia monitoring enables reliable assessment of adequate drug dosing.
The last point is crucial. Using processed EEG monitoring to measure depth of anesthesia is not just about sustainability, it's about patient safety and precision medicine.
Absolutely.
So, Alain, where do we go from here? What are the top priorities for making anesthesia in cardiac and thoracic surgery more sustainable?
Well, every department should focus first and foremost, if it's not done yet, in eliminating desflurane. It's the easiest and most impactful change. Even switching from desflurane to sevoflurane already reduces the climate impact by over 95%, rendering desflurane use during anesthesia absolutely indefensible. Secondly, making TIVA the standard for cardiac anesthesia, particularly during CPB where volatile anesthetics lack any justification. Also, importantly, recognizing that volatiles have absolutely no proven benefit over TIVA. There are no data demonstrating the superiority of volatile anesthetics over TIVA in terms of mortality or morbidity. So this means that the patient experiences no negative effects whatsoever when switching to environmentally responsible anesthetic techniques. Also important is optimizing resource management, so cutting down on single-use plastics and avoiding unnecessary hyperoxia, and measuring depth of anesthesia, as told, to prevent excess anesthetic administration for both volatile and intravenous techniques. And finally, what's also important is expanding regional anesthesia in thoracic surgery to reduce general anesthetic requirements.
So, if there's no patient-centered reason to keep using volatiles, why are we still doing it? The environmental impact is enormous and the alternatives are already here. Alain, any final words?
Well, certainly, we cannot afford to wait. The climate emergency is really uh, pushing us towards sustainability in anesthesia. And it's not about compromising patient care, it's about aligning clinical best practices with environmental responsibility. The solutions are available today. We don't need to wait for more innovations, and it's only up to us as clinicians to implement them now. TIVA is both much less polluting and much cheaper than volatile anesthetics.
Thanks for joining us on the future of anesthesia. Let's work together for a greener, more responsible future in our specialty.
Thank you.